Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KPL number 6. So we have already completed 5 KPL so far. Today is the turn for KPL number 6, and if you have downloaded the question paper and solved it, then you can continue watching this video. But if you have not downloaded the question paper, go visit our WhatsApp channel, link is given in the description, and then you download the question paper, solve it quickly, then you can come back and watch this video. Till then, let's start. Those who have completed their question paper, they should check if the answers are correct or not, or those who have tried to solve the question paper and they are not able to solve, they should realize why they are not able to solve these question papers. So let's start. For those who have already completed this and those who have not yet completed, or those who don't even have the question paper, I request them to download the question paper first before going through the solution. Otherwise, it will not help you anyway. Right? So first question was, an equiconvex lens made of glass of refractive index 3/2 has a focal length f in air. It is completely immersed in water of refractive index 4/3. The new focal length will be. So what was the question? The question was, initially the focal length was f, and from lens maker's formula we have to use lens maker's formula to solve this question. Okay, so what was the lens maker's formula? If you remember, 1 by f equals to n minus 1 divided by 1 by r1 minus 1 by r2. Okay, now for equiconvex lens, r2 equals to minus r1. Okay, so what we can do, we can write this formula for equiconvex lens only. This formula becomes n minus 1 by r1 plus 1 by r1. If you insert the value of minus r1, it will become plus, so it will become n minus 1 2 by r1. Right, you remember this. I have already solved similar questions. Now what they have said, when it was in air, okay, the refractive index of the glass is 3/2. So in air, suppose the focal length is f air and that value is given f. So the focal length will be 3/2 minus 1 times 1 by r1. Right? So in air, or 1 by fa equals to 3/2 minus 1 is 1/2. Okay. So times 2 by r1. So 2 cancels. So fa is r1. Now this is given as f. fa is given as f. Right, in the question it is mentioned that the focal length in air is f. Now when you immerse it into water, the total refractive index or the effective refractive index will become refractive index of the material, that is glass, divided by refractive index of the surrounding materials, that is water. So 3/2 divided by 4/3. So it will become 3/2 times 3/4. It will go up and it will inverse, right? We know that. So 9/8. Now what is the refractive index when it is immersed in water? So FW, say FW is, again the formula will be same. So n effective minus 1 times 2 by r1. So n effective we have calculated 9/8. 9/8, right? Minus 1 times 2 by r1. Okay, 9/8 minus 1 is 1/8, right? So you can check that. It will come out to be 1/8 times 2 by r1. So it will cancel and you will get 1 by fw is nothing but 1 by 4 r1, or fw is equal to 4 r1. Now in the first equation we have calculated f equals to r1. So we just need to replace that. So it will be 4f. So 4f is the new focal length. 4f is the new focal length, right? Now let's move on. A mark is made on the bottom of a beaker and a liquid of refractive index 1.2 is poured to a height of 6 centimeter. When viewed vertically from the top, the mark seems to be raised by an amount. So what is that? You have a liquid, okay, and there is a mark at the bottom of the beaker and you have poured a liquid of 6 centimeter. Okay, and the refractive index of the material is 1.2. Now the question is, as we know that as the water refracts from the surface, okay, the height will be raised. Okay, so initially suppose the height is u and the final height is v, then there is a formula. What is the formula? U by v equals to mu. Okay, u is the initial distance, original distance, and v is the distance, apparent height. Okay, apparent height. Then we say u by v. I am using the term u and v so that you don't are familiar with object distance and image distance. So basically this is the object distance, this is the image distance. So virtual apparent height is nothing but an image of the bottom, right? So that's why I have used this, and this is equals to mu. Mu is given as 1.2, u is given 6 centimeter, and they have asked you raised by an amount. Raised by an amount means you have to find this height. That means u minus v. So do that, you have to first find v. V is 1.6, 1.2. Okay, so v equals to 6 divided by 1.2, right? So 6 divided by 1.2 is v. So what is the value? You will cancel, you will get 5. Okay, 5 12 is 60, but there is a decimal, so 60 means 5 times 1.2 is 6, right? So it is 5 centimeter. But if you answer it 5 centimeter, you will get wrong. Okay, because the correct answer is how much it is raised. So raised was u minus v, that is 6 minus 5, that is 1 centimeter. Okay, so correct answer is 1 centimeter, not 5 centimeter. If you have answered 5 centimeter, you are partially correct, but your answer is not correct because they have not asked you 5 centimeter, but they have asked you how much they have raised, and that is 1 centimeter. Read the question, understand it before answering. A point source of light is kept below the surface of water, NW is equal to 4 by 3 at the depth of 7 meters. The radius of the circular bright patch of light noticed on the surface of the water. This is also very interesting, similar question but not exactly same. Okay, so what they have said that the refractive index of water is 4 by 3. Okay, so refractive index of water is 4 by 3 and they have kept a source of light here. Now as we know that light will traveling from denser to rarer medium, after some time it will be doing a total internal reflection, and because of that you will get a circular patch over here because it's a flat surface. Eventually you will get a circular patch, and they have asked you to find the radius of the of this patch. So how can we find the radius of this patch? Very interesting question. So we are trying to find this radius. Okay, now how we can do that? So to do that, what we have to do, we have to draw the normal at this point. Now also at this point. Now when this is this happening? This is happening when this angle is equals to the angle of critical angle, right? Similar problem is there in your CBSE NCERT book. So also it came I think last year's PU board paper as well. So if you are not sure, you can check that as well. This is going to be helpful for your PU board exam as well, and as well as KCET exam. This is a very standard problem. So this is the critical angle. Now if this is the critical angle, then this angle will be 90 degrees, right? Now we know that there is a relationship. If the refractive index of the medium is n, then we can write this as sine theta c equals to 1 by n, if you remember, right? So 1 by n is the refractive index. Now here 1 by n is given by 4 by 3. So n is given by 4 by 3, so 1 by n will be 3 by 4. Clear? So why it is 3 by 4? Because n itself is 4 by 3, right? Now we are not going to find theta c using this. Very clear, okay? We are not going to find theta c using this. What we will be doing, we will apply the corresponding angle. So if this angle is theta c, this angle will also be theta c, right? Z, whenever there is a z, these two angles are equal, corresponding angle, right? Or sorry, alternate angle in this case. So they are equal. Now if this angle is equal, the height or depth of the water is given as root 7. Right? So what we will be doing, we will be applying that and we will try to find the radius. This is what we are trying to find, right? Now if this distance is r, this is root 7, this height is root 7, right? And then what is sine theta? This is theta c, so we will try to find sine theta. So sine theta is perpendicular by hypotenuse. Perpendicular, this is the angle, so this is the perpendicular by hypotenuse. Now what is hypotenuse here? So if suppose this is hypotenuse, hypotenuse is from Pythagoras theorem, it is base square plus perpendicular square, then square root of everything, right? So root 7 square is 7, r square is r square, and then whole root of that is the sine, is the hypotenuse. Now from there we can write this as perpendicular by hypotenuse. Now perpendicular is r, hypotenuse is square root of 7 plus r square, right? So now let us write this. This is from the triangle and this is from the given data, right? So 3 by 4 is equals to r by square root of 7 plus r square. Now to solve this, what is creating an issue? This square root is creating an issue. So what we have to do, you have to square both sides. So if you square both sides, then we can write 9 by 16 equals to r square divided by 7 plus r square, right? So now do the cross multiplication, then we will get 7 9s are 63 plus 9 r square equals to 16 r square. Okay, so what we can write here now? Now let us take this 9 r square to the other side. So 16 r square minus 9 r square equals to 63, or 16 minus 9 is 7, 7 r square equals to 63. Okay, so what is the answer now? So r square equals to 9, 7 9s are 63, so r equals to 3 centimeter. So r is 3 centimeter. So correct answer is D. Okay. So be careful, don't fall in any traps. If you don't fall in any traps and do the calculations properly, 90% of time you will get the correct answer, unless you make some correction mistakes. So 10% is there for calculation mistakes. Okay. Now question number 4. A ray of light traveling in a transparent medium of refractive index n falls on a surface separating the medium from air at an angle of incidence of 45 degrees. For which of the following value of the ray, value of the n, the ray can undergo a total internal reflection. Okay, so here the angle of incidence is given 45 degrees. Okay, so if this angle is exactly equal to the critical angle, okay, if this angle is exactly equal to the critical angle, then what is the required refractive index. So if this angle is exactly equal to the critical angle, then we know that sin theta c is equals to 1 by n. So sin 45 should be equals to 1 by n. What is sin 45? Sin 45 is 1 by root 2, right? So 1 by n. So from here we can write n equals to root 2, that is 1.414. So if the refractive index is greater than this value, this is exactly this is the boundary, this is the border line, right? For this it is not totally reflecting yet, but for this it is still at the critical level. If the refractive index is greater than 1.414, then definitely it will have a total internal reflection, right? From the given data, if you see, all the values are less than 1.414 except 1.5. Okay, now you might think, okay, this is the closest answer, so this will be the answer. No, in this case we have to see whichever is greater than this value. Okay, in this case we can see only one value is greater than this, so 1.5 is the answer, not 1.4, even though it is closest. Okay, be careful while answering such questions, because this is not the closest, it is greater than this value, so greater than any of this value, and as you can see it is given 1.40 purposefully, so that you can clear the fact that this is actually less than that of 4.41, right? So that is why there is only one answer, that is 1.5. Now I have solved this question while doing our regular lecture. So here they have said that a ray of light passes through 4 transparent media with refractive index N1, N2, N3 and N4 as shown in the figure. The surface of all the media are parallel if the emergent ray DE is parallel to the incident ray AB. Okay, so here it is AB. Okay, and this is D. So if they are parallel, then which of the following is correct? So as I said, if this ray is parallel to this ray, then obviously this refractive index should be equals to this refractive index. So right, so from there we can write that N1 should be equals to N4, that is option B is correct. Now question number 6, if a glass rod is put in a beaker containing a colorless liquid, the glass rod immediately seems to be disappear. If you have seen YouTube videos, there they show some magic tricks, okay, saying that this is a refractive index. Okay, when initially it was completely visible, they make it disappear. Okay, then suddenly it came back again. So that is nothing but when refractive index of two medium are same, that is equal. Okay, light ray do not reflect back from that medium, they only pass through it, so that medium appears to be disappeared. Okay, so that's why we can say that the refractive index of the glass and the liquid have the same value. Okay, so the glass and the liquid have the same refractive index. Okay, if you are thinking they have the same color does not matter. Okay, even if they have same color, if it is a liquid, if it is a solid, they can still be visible. Okay, you can try it using some coloring paper and color at your home. But if they are have the same refractive index, definitely it will disappear. Okay, now a diver on a diving board estimates the depth of water in a swimming pool to be 18 meters. The percentage error in the estimation is, the refractive index of water is 4/3. So first of all, what we have to do, we have to find the actual depth. So we already told you the formula, U by V is equal to mu. So U, we don't know here, in this case U by V equals to mu, right? We don't know U, but we know that he saw it apparently 18 meters. So apparent depth means V, right, equals to 4/3, right? So from here we can calculate U equals to 4/3 times 18, 3 6 18, so 24 meters. Okay, 24 meters is the actual depth. Now what is the percentage error? So actual depth is 24, measured depth is 18, and percentage error should be in terms of actual depth times 10 to the times 100%. Okay, so 24 minus 18 is 6. 6 divided by 24 times 100%. So it will be 1,425%. So the percentage error in the measurement is 25%. Okay, so the 25% is the correct answer. Okay, clear? Next question. 3 Polaroid sheets P1, P2 and P3 are kept parallel to each other such that the angle between pass axis of P1 and P2 is 45 degree and that between P2 and P3 is 45 degree. So we have 3 polarized sheets. I am just drawing their axis. So first P1, this is P2 and this is P3. P3 and P1 are parallel, perpendicular, as you can see. Okay, but this angle is 45 degrees. This angle with this is 45 degrees. And which law we will use here? We will use Malus law, which says that the intensity of the light passing up through a Polaroid is given by I naught cos square theta. Okay, cos square theta. This is the simple formula. Now when a ray of light passes through a Polaroid for the first time, if the intensity say I, then after first refraction it becomes I by 2, right? So after first refraction it becomes I by 2. So in this case, for the first case, it will be I by 2. To let not be confused, I am mentioning the final refractive index. So this is the P2, I dash, and this will be I double dash, say. Okay, now I is given as 128 watt per meter square. Okay, I is given as 128 watt per meter square. So 128 by 2 cos square 45 degrees. Okay, so 64 cos square 45 means 1 by root 2 whole square, that is 1 by 2. So 32. Right, now what is the final refractive index? Final intensity I double dash is I dash cos square 45 degree. Again another cos square 45 degree because the angle between next two is also 45 degree. So I dash is 32, right, 32, yes, times cos square 45 degree, we have already said it is half, so it will be 16. So final intensity of the light coming out is 16 watt per meter square. 16 watt per meter square is the final intensity. Be careful, when an unpolarized light passing through a first Polaroid, the intensity decreases by half, and there onwards it is Malus law. So these two steps you have to remember to answer such questions. Now, which mirror is to be used to obtain a parallel beam of light for small lamp? So parallel beam of light means after reflection it will become parallel. Okay, so we know that, and for a small lamp, okay, it is not a very large object. So we know that only concave mirror, when the object is placed at the focus, okay, when the object is placed at the focus after reflection, the rays become parallel, right? They all meet at infinity. So only concave mirror can be used to get a parallel beam of light, right? The frequency of light ray is 6 times 10 to the power of 14 Hz in air. Its frequency when it is propagates in a medium of refractive index 1.5. Now this is a very clever question. Refractive index of frequency of a light does not change with refractive index. or anything else. Okay, frequency of a light is a universal constant. Any light, given light, okay, as long as it is propagating, it is not getting absorbed, its frequency will remain constant in matter of it, which medium it is traveling through. Okay, what is the speed of light in that medium? Speed of light can change, wavelength can change, frequency will not change. Okay, I gave you one example. Frequency is like the identity card. Okay, frequency is the Aadhaar card of light ray. Okay, its age can change, its picture will change, but Aadhaar card where fingerprint, everything, all the data are given, that is constant, right? Similarly, for a ray of light, frequency is its Aadhaar card. So Aadhaar card has to be there, so it should be same. Okay, 6 times 10 to the power of 14 hertz. So it will remain unchanged. Simple question. A linear object of height 10 centimeter is kept in a front of a concave mirror of radius of curvature 15 centimeter. At a distance of 10 centimeter, the image formed is. So what type of mirror they have used? They have used concave mirror. Okay. Now radius of curvature is 15 centimeter. Okay, so radius of curvature is 15 centimeter, R is 15 centimeter. Okay, you don't need to do any mathematics for this case, and focal length will be R by 2, that is 7.5 centimeter. As long as you understand the problem, you don't need to do any mathematics. So focal length and radius is 15 and 7.5. Now the object distance is 10 centimeter, right? So object distance is 10 centimeter means object is placed between R and F. So object is placed between R and F, that means the image will be enlarged, inverted and enlarged. Okay, so magnified and inverted, that should be the answer. Okay, between R and F the image is inverted, but it is enlarged or magnified. So magnified and inverted should be the answer. Okay, if it is beyond R, that is far away from R, then the object is inverted, but it is not magnified, it is diminished. Okay, if the object is further than F, that is it is closer to the mirror and the distance is less than F, then image is magnified but it is erect. Okay, so in that case it is virtual image, so you remember that. So virtual image means it is erect and magnified. A beam of parallel light rays is incident on a solid transparent sphere of refractive index mu. If a point image is produced just at the back of the sphere, what is the refractive index of the sphere? So what is this case? We have a sphere. Okay, a parallel ray of light falling on this sphere, they are forming an image at the back of the sphere, right? So this is what happening, right? In this case, what matters is only this surface matters. Okay, you can ignore this surface because everything is happening from this surface only. Okay, so you can consider this is as the refractive sphere. Now if you consider this as the R as the radius of curvature, okay, now we can write that now this is the image distance, right? Before writing the equation, let us find the image distances. Okay, so radius of curvature is R, that means image distance, that is from here to here, that should be the image distance should be 2R, right? Now where the image is forming, so let us say the refractive index of this is given mu, this is air, so refractive index is 1, right? Now we know that for a spherical surface N2 by, this is N2 by the way, if you are wondering, this is N1, N2 by V. So N2 is inside this and V is also happening here. So N2 by V minus N1 by U equals to N2 minus N1 by R. If you remember the curved surface formula, using this we actually derived the Lensmaker's formula. Now N2 is mu. So mu by V, V is 2R. V is also known, not exactly but in terms of radius of curvature is known. So mu is 2R minus 1 by U. So the parallel ray is coming. Parallel ray is coming from where? So whenever there is a parallel ray, that means object is located at infinity. So object is located at infinity means it should be infinity. Okay, equals to mu minus 1. Air is 1 divided by r. Right, now what we have to do, you have to just simplify this. Now this value 1 by infinity goes to 0. 1 by infinity means 0, right? We already know that 1 by 0 is infinity, 1 by infinity is 0. So mu by 2r equals to mu minus 1 by r. Now this r cancels. So after cross multiplication, these two will multiply here. So mu equals to 2 mu minus 2, right? 2 mu minus 2. So now you take this minus 2 on this side and this mu on the right hand side, you can write 2 equals to 2 mu minus mu, or 2 mu minus mu is mu equals to 2. So the refractive index is 2. Okay, little complicated problem, but not very difficult in terms of mathematics. If you remember this formula, you can answer this question. Okay, now the image of an object in concave lens is formed at f by 2, where f is the focal length of the lens. Find the distance of the object from the lens. So lens equation, simple lens equation, we are not even drawing any picture. We know 1 by v minus 1 by u equals to 1 by f. Okay, now what type of mirror it is? It's a concave mirror, so focal length is negative, right? Image is formed at f by 2. Image is formed at f by 2 means image is formed on the same side as the object for concave lens, not concave mirror, concave lens, right? So image distance should be negative, f by 2. Okay, object distance is also negative, minus u. Lens, this should be also negative, minus f, right? So let us solve this. 2 by f minus plus 1 by u equals to 1 by minus f, right? So 1 by u equals to 2 by f minus 1 by f. Okay, so f is common, 2 minus 1, that is 1 by f. So u equals to f. Now here the sign does not come as negative because we have already used the sign of u as negative here. So the correct answer is f. Okay, simple problem, just apply the formula, calculate it with the proper sign convention. Sign convention is important. Okay, if you are still having doubts in sign convention, you can mention that in the comment below. While doing the revision of the chapter, I will going to do the sign convention once more. Okay, blue color of sea water is due to, very easy question, image of the sky in water. Okay, so blue color of the sea is not because something is there in the water. It is because the sea water reflects the sky. There is nothing between sky and the water, so you can easily reflect the sky and it appears blue. Okay, red color is used for danger signals. Another easy question. Okay, because it causes fear. Is it causes fear? Red is color of blood. Some people might say, so maybe they are thinking, okay, it causes fear. No, it undergoes least scattering. Okay, it undergoes least scattering, so that you can see the red signal from a very far distance as well. So if you are driving and you are seeing that there is a red signal at a very from far, then you can, what you can do, you have to slow your vehicle down so that you don't run past. Similarly, a train is moving at a very high speed, okay, and if he sees there is a red light from afar, he has the time to slow the train down so that we can avoid any mishaps. Okay, this is the main reason. Okay, it is there for vehicles as well as train signals as well. Okay, so train signals, even the planes when they are going to fly, okay, they are using signal system. So red signal is visible from a very distant far apart. Okay, so that whenever there is a red signal, the driver gets cautious and he can slows his train, he can slows his vehicle so that there is no accident. Okay, so it is because it scatters very less. A ray of light suffers a minimum deviation when incident on an equilateral prism of refractive index √2. The angle of incidence is. Okay, they have asked you to find the angle of minimum deviation, angle of minimum incidence when this is happening, minimum deviation, right? Now, if you remember the minimum deviation graph, okay, minimum deviation occurs when I equals to E, right? I equals to E, then only minimum deviation occurs. Now, we know that mu equals to sine A plus delta minimum by 2 divided by sine A by 2, right? Now, it is a equilateral prism. Equilateral prism means A should be equals to 60 degrees. So, A by 2 should be equals to 30 degrees. So, what is the value of sine A by 2? So, sine A by 2 should be equals to half, right? And mu refractive index n is given by √2. So, √2 equals to sine A plus delta m by 2 minus by sine 30, that is half. Okay, so this half will come here. So, we can write sine A plus delta m by 2 equals to 2 times √2 times half, that is 1 by √2, right? What is 1 by √2? 1 by √2 means sine 45 degrees, right? So, A plus delta m by 2 is 45 degrees, or delta m A plus delta m equals to 90 degrees, or delta m equals to 90 minus 60 degrees. Okay, so that is equals to 30 degrees. So, delta m we have received 30 degrees. But they have asked you to find the angle of incidence. Very, very clever question. So, if you leave the answer here and mark 30 degree, you are not getting the full marks. So, what is the angle? We know delta m is equal to A minus 2i, right? So, delta m is A minus 2i. So, delta m is 30 degrees equals to 60 minus 2i. Now, the minimum angle of deviation in terms of incident angle and angle of prism is given by 2i minus a, right? So, minimum angle of deviation we have calculated is 30 degrees, right? So, and A is equilateral triangle. So, equilateral triangle means A should be 60 degrees, right? So, let us put those values and calculate it. 30 degrees equals to 2i minus 60 degrees. Okay. So, 2i is 30 plus 60, that is 90, that is I equals to 45 degrees. Okay. Any confusion, any doubt, you can mention that in the comment below, but this is the correct answer. Very tricky question, okay, not because it is hard, formula wise everything is known. The main problem is student find it tricky because they leave the solution here and mark it, which is completely not acceptable, because after you have reached this answer, that means it is only less than 5 seconds to calculate it. Okay, only one more formula is there. Okay, delta m is equal to 2i minus a. If you remember that, you can answer that, right? A focal length of a lens is 10 centimeter. What is the power of the lens in diopter? Oh my god, this is a very, very easy question, right? So, power is 1 by f, but f is in meters. In terms of centimeters, we use this formula when f is in centimeters. Only this thing you need to know, right? So 100 divided by focal length is 10 centimeter, right? So it is 10d plus 10d, okay, because focal length is given positive, so it should be plus 10d, okay. The focal length of a biconvex lens of refractive index 1.5 is 6 centimeter. Radius of curvature are in the ratio of 1:2. Then the radii of curvature of the two surfaces are. Oh my god, very difficult question. So first of all, let us assume the radii of curvature of the first one is r. Okay. Then the second one will be 2r. Ratio is 1:2. So if we assume the first surface of radius of curvature r, then the second one will be 2r. Now what type of lens it is? It's a biconvex lens. So if first one is r, second one will be not only 2r, it will be also negative, right? So first surface is this one, r, second surface is this one, it is 2r. Right, so 2r should be negative, r should be positive. It is along the positive x-axis, this is along the negative x-axis, right? So first of all, we have to fix these two values. Now what we have to do? What else we have to do? Yes, we have to use the lens maker's formula. 1 by f equals to n minus 1 by r minus 1 by minus 2r. Okay. Let me simplify this first. N minus 1 LCM is 2r. Now this minus minus become plus. So LCM is 2r. So it will become 2 plus 1. So n minus 1 times 3 by 2r. Okay, this is equals to 1 by f. Now let us check all the values. So refractive index is 1.5. and focal length is 6 centimeter. Okay, so these are all given. So let us now put the values. 1 by 6 centimeter equals to 1.5 minus 1 times 3 by 2r. Okay, now what you have to do? You have to do the cross multiplication. So first 2r will come here. 2r equals to 1.5 minus 1 is 0.5, right? Times 3 times, so 1.5 minus 1 is 0.5, 3 is 3, this 6 will come here and becomes multiplied by 6. So this we can cancel like this. So r becomes 0.5 times 3 is 0.5 is 1 by 2, right? And 3 3s are 9. So 9 by 2, that is 4.5. So it is 4.5 centimeter. Now you can calculate the other one, but if you see the answers, you see the options, only one has 4.5, none other has 4.5. So you can simply mark it. But if there is a confusion, what you can do? The other r is 2r. Okay, other radius of curvature is 2r. So 2 times 4.5, that is 9 centimeter. Okay, so the correct answer is this. This is the combination, right? Now let's move on to the next question. An object placed at a distance of 16 centimeter from a convex lens produces an image of magnification m. M is greater than 1. If the object is moved towards the lens by 8 centimeter, okay, then again an image of magnification m is obtained. The numerical value of the focal length of the lens is. This is a very interesting question. Okay, first case when the object is at 16 centimeter, you are getting a magnification m. Okay, and the second case when the distance is you are moving it towards the lens, right? And that means this one will be a virtual image. Okay, this one will be real image. Okay, so for real image we can write that v by u equals to minus m. Okay, magnification is m. Okay, and because it's a real image will be definitely be inverted, so the sign will be negative. Now u is given 16, so v by 16, this is case number 1, okay, is equal to minus m. So v is equal to minus 16 m. Okay, from here we can write 1 by V minus 1 by U equals to 1 by F, right? So 1 by V is minus 16m, okay, and U is minus 16. So what is the value of F? So 1 by F equals to 16m. One more thing, this U will be negative, right? So this U will be negative means B should be positive. B is on the other side. That's what I am thinking, why it is coming negative. Okay, so 1 plus m, right? So this is the F from the equation 1. Now let us consider the equation 2. In equation 2, this is definitely be a virtual image, because as you have moved in towards the lens, okay, you are getting again having the same magnitude, and magnitude both cases is greater than 1. So only a case where it is happening when you are using a convex lens and you are pushing the object towards the lens, right? So in this case, V by U equals to plus m. Now V we don't know, okay, U is minus 8, okay, equals to m. So V will be equals to minus 8. Okay, now again apply the lens formula. 1 by V minus 1 by U equals to 1. Sign is very important. Okay, many students ignore sign and still sometimes signs are getting cancelled, or due to some reason they are getting the correct answer. But if you ignore the sign, 3 out of 4 times you are going to get it wrong. Okay, 3 out of 4 times. Okay, don't ignore sign. Okay, 1 by V, V is minus 8m here, U is minus 8 here, equals to 1 by F. Okay, and what is 1 by F? 1 by F is nothing but 1 plus m divided by 16m, right? We have already calculated that. Now what we have to do, we have to equate that. Now you can write minus 1 by 8m plus 1 by 8 equals to 1 plus m divided by 16m. So using this we are going to calculate m, and then any equation we will put the value and we will calculate the value of f. Okay, so first let us simplify this. 8m and 8, what is the LCM? LCM will be 8. Okay, 8, and because there was 8m here, LCM will be 8m. So here we will get minus 1 because 8m is already there, and plus m because only 8 was here. So in this case we will get m minus 1 by 8m equals to m plus 1 by 16m. M cancels, 8 2s are 16. Now do the cross multiplication. So cross multiplication means 2m minus 2 equals to m plus 1. Okay, so what we have to do, if you take this m in this side, so you will get 2m minus m equals to 1 plus 2. So you are getting m equals to 3, right? So you have obtained m is equal to 3. Now put the value here in this equation. 1 by f equals to 1 plus 3 divided by 16 into 3. So f will become 16 times 3 divided by 1 plus 3, that is 4. So 4 3s are 12. Okay, so the correct focal length is 12 centimeter. Little longer but not so difficult, I feel. Okay, even though it is little lengthy question, not so difficult, you can solve it. Okay, a plano-convex lens have a refractive index mu and radius of curvature r. Its focal length is this is simple lens maker formula. 1 by f equals to n minus 1. Here n is given as mu, and we already know that it is 1 by r1. Now for a convex lens, equiconvex lens, it is equals, both sides are equal, and one side is negative of the other, so we can write is minus r. So mu minus 1 by r plus 1 by r. 1 by r plus 1 by r is 2r, 2 by r. So mu minus 1 2 by r. So this is 1 by f. So what is f? F should be r by 2 mu minus 1, right? So r will now be on the upside, 2 times mu minus 1 will be in the denominator. So r by 2 times mu minus 1. Option D is the correct answer. Okay, tricky question but easy. When a biconvex lens of glass having refractive index 1.47 is dipped into a liquid, it acts as a plain sheet of glass. Okay, in this implies that the liquid must have the refractive index equal to that of the glass. Right, a convex lens, you dipped it into a liquid, it is behaving as a plain sheet of glass. Plain sheet of glass means it's a simple glass, right? So that means the refractive index should be equal to that of the refractive index of the liquid. Then only it can behave like a plain sheet of glass. Now we are moving so far we have only solved one question from wave optics. All the questions from here on are from wave optics chapter. Let's look into the questions. In Young's double slit experiment, the source is white light. One slit is covered with red filter and other with blue filter. There shall be no interference, because to observe interference, light should be in the monochromatic order. Okay, in case of white light, you get only very few level of interference. Okay, very few order of interference with the central bright fringe as white, and then 1 or 2 colored fringes, then everything is white again. Okay, but in case of yellow and red light, you will not get any interference. Okay, you will not get any interference. The wavelength of light used in YDAC. YDAC is a short form of Young's double slit experiment. So if you are wondering, that is why previous question we have mentioned Young's double slit experiment. In your exam they will mention the full name, but since it is a test series, we are trying to make you familiarized with the different terms as well. So YDAC is Young's double slit experiment is lambda. The intensity at a point on the screen where the path difference is lambda by 6 is I. If I naught denotes the maximum intensity, then the ratio of I and I naught is. Okay, we know that maximum intensity occurs at the central bright fringe. So at the central bright fringe, I naught equals to 4I. Okay, here I is the intensity of the incident light. So incident light, let me write this as II. Okay, so intensity of the incident light is II, and they have asked you to what is the intensity when the path difference is lambda by 6. So path difference is lambda by 6. So phase difference is 2 pi by lambda times delta x. So 2 pi by lambda times lambda by 6. So lambda cancels, it cancels 3. So it is pi by 3. Right? Now what is the intensity? Intensity I is 4 II cos phi by 2, or I naught cos pi by 6. Right? Pi by 6 means what? Pi by 6 means 30 degrees. Right? Cos 30 degrees is root 3 by 2. So I naught root 3 by 2. So what is the ratio of I and I naught? So I by I naught is equals to root 3 by 2. Okay, so correct answer is root 3 by 2. Right? Next question. Two waves represented by y1 is equal to 3 sin omega t and y2 is equal to 4 sin omega t plus pi by 3 interference at a point, then the amplitude of the resulting wave will be. Very interesting question. So we know that if y1 equals to a1 sin omega t and y2 equals to a2 sin omega t plus phi interfere. Okay, both of them should be sine. Then the resultant wave will have, say, resultant wave y should have a amplitude into sine some value. Okay, then that amplitude is given by a is equal to square root of vector addition. Remember vector addition, a1 square plus a2 square plus 2a1 a2 cos phi. Okay, so what is a1 here? A1 is 3, so 3 square plus what is a2? A2 is 4 square plus 2 times a1 a2 cos pi by 3. Cos pi by 3 means cos 60 degrees, right? Now let us put the values. 9 plus 16 plus 3 2 is 6, 6 4 is 24 times cos 60 means half, so 12. So what we get? We get 25 plus 12, that is square root of 37. But this is not, this is a prime number, but all the answers are given in single digit answer. How it is so? Because 37, if you see, is very close to a number 36. 36, square root of 36 should be equals to, it is possible, so we can do it 6. So correct answer is 6, closest answer obviously, right? Now let's move on. While both light and sound show wave character, the diffraction is much harder to observe in light. Now diffraction is observable in sound, it is happening every time. Okay, then that is why, that is because you can hear sound when you are listening to someone else's room and you are hearing sound from other room. That is because of sound, some part of diffraction is responsible for that, right? Now it is easier for sound wave but not so easier for light wave, because we know that the bending of light around a sharp edge is called diffraction, right? Now bending of sharp edge, the edge should be as sharp as of the order of the wavelength of the light. So if the wavelength of the light is very small, okay, if the sharp is flat, what it will happen? It will absorb that light. It will not even try to diffract. It will only simply absorb it, or sometimes it will reflect it. Okay, diffraction will not happen. To observe diffraction, this sharpness should be of the order of the wavelength. Okay, it should be very sharp, so that when the ray of light falling on this, they are diffracting. Okay, like this. Now because the wavelength of light is very small, it is very difficult to get sharp object in our day-to-day life. Okay, even though we are using very sharp objects such as knife or some other things, but they are not super common, right? So they are also have a specific purposes. That's why we don't see diffraction too often in our day-to-day life. We have to clear some, we have to do some special arrangement to observe diffraction, right? So light, wavelength of light is very small. Okay, so wavelength of light is far smaller, that's why it is difficult to observe diffraction for light. You should remember this. A slit of width A is illuminated by white light. The first minimum for red light, lambda is equal to 6500 angstrom, will fall at theta equals to 30 degree when A will be. So now we know that A sin theta equals to n lambda for first for diffraction minimum, right? Now they have said that slit is illuminated by white light, the first minimum for red light. First minimum means n equals to 1. Okay, so A sin theta is 30 degrees, given already, everything is given, only thing you have to plug the values and calculate the answer. It is 6500. Okay, A sin 30 is half, so it is 6500 in angstrom. Angstrom means what? 10 to the power of minus 10, right? Meter. So A will be 2 times 6500 times 10 to the power of minus 10. Okay, so 2 times 65 is 130. So A equals to 130, and then how many zeros? 1 2 times 10 to the power of minus 10 meters. Now 1 2 3 4. So if I write it like 1.3, then it will become 10 to the power of minus 6, 4 less, right, meters. So 10 to the power of minus 6 is micrometers. Micrometers is also also called microns, right? So 1.3 micron is the correct answer. Last 3 questions. To observe diffraction, the size of the obstacle should be of the order of the wavelength. I mentioned this just few slides back. Okay, a single slit of width A is illuminated by violet light of wavelength 400 nanometer, and the width of the diffraction pattern is measured as y. When the half of the slit width is covered and illuminated by a yellow light of the wavelength 600 nanometer, the width of the diffraction pattern is. Now if you remember, we have done the width of the diffraction pattern calculation, right? Okay, so this was the first diffraction order. Second order, in that case we said A theta equals to n lambda, so theta 1. Okay, so this was the theta 1 angle. Okay, so we said that theta 1 is n lambda by A. For diffraction first order minimum, it will be lambda by A, and then we said the width is given by 2 theta 1, that is 2 lambda by A. Okay, so this was the angular width. For angular width, the linear width are proportional. So even if you are considering angular width, your problem will be not changed, your answer will not change, right? So now what they have said, first of all, they are using violet light of wavelength 400 nanometer, right? So for violet light, what was the width? Width is y. It was given width is y. So y equals to 2 times 400 nanometers 10 to the power of minus 9 by A. Okay. Now what they have done? Now they have covered the initially the suppose the slit width was A, right? So this was the width of the central maximum. Now what they have done, they have covered the half of that. Half of this is covered now. Okay, only half is open. Now what is the slit width left now? Slit width will be A by 2. And what light they are using now? They are using yellow light of wavelength 600. So from here we can write the new width equals to y1 equals to 2 times 600 divided by A by 2. Okay, why A by 2? Because new width is A by 2. So it will be 4 times 600 by A. Okay, so it will be, now if you calculate here, it will be 800 times 10 to the power of minus 9 by A. Here it will be 4 6 2400 times 10 to the power of minus 9. Why 10 to the power minus 9? Because it is in nanometers, right? Divided by A. So if you see 3 8 is 24. So this is nothing but 3y. Okay. So 3y is the correct answer. Okay. Little tricky but solvable. Diffraction pattern is observed using green light. When green light is replaced by red light, no changes is observed. The bands become narrower and crowded. Bands become broader and well separated. Bands disappear. So we know that the width, just we solved in the previous problem, width is given by 2n lambda by A. So if you know that green light, what was the spectrum? BFGR, right? It has the highest wavelength, lambda highest. It has a smaller wavelength. Okay, so higher the wavelength, band will be broader, right? So what they have done, initially they are doing with green light, now they have replaced green light with red light, so the bands become broader and well separated, because this is the separation will also increase and bands will also become broader, because bandwidth is directly proportional to the wavelength of light. So wavelength, you are increasing the wavelength, so the bands will become broader. Last question, this is question number 30. Which of the statements are correct with reference to the single slit diffraction pattern? Fringes are of equal width, fringes are of unequal width, fringes are of equal width, light energy is conserved, intensities of all bright fringes are equal. Okay, single slit diffraction, fringes are of unequal width. We know that central fringe is much brighter and broader, other widths are neither that much bright nor they are same width is also getting smaller. So but energy will always be conserved. So option 1 and option 3 is the correct answer. Now if you have any doubt, any question regarding this question paper or anything else that you are studying, don't forget to mention that in the comment below. Subscribe to our channel if you have not yet subscribed to our channel, and I will be back with a new video tomorrow. Thank you.